Today we're going to talk about simplifying radicals, but before we start with radicals, let's just look at numbers and some of their factors and see what we're looking for. So on the screen I have four numbers, 48, 125, 32, and 98. And if I ask you what do these numbers have in common, well, one thing that you might discover is they each have a factor that's a perfect square. So for example, 48 has a perfect square that is 16. So 16 times 3 is 48. 125 has 25 times 5. 98, 49 times 2, 49 and 25 are the perfect squares. And 32 has 16 times 2, and 16 is the square root. Now let's look at four counterexamples, 42, 17, 22, and 6. Let's start with 6 and look at all the factors. 1 times 6, 2 times 3. Only one of these is a perfect square, which is 1, and for our purposes 1 isn't very exciting. So none of the other three factors are a perfect square. Let's look at 17. 17 is a prime number, so it only has 1 in itself. So that doesn't have a perfect square as a factor. 42. 1 times 42, 2 times 21, 6 times 7, 3 times 14. Well, again, having a quick look, except 1, none of these are perfect squares. And last but not least, let's look at 22. 1 times 22, 2 times 11. Besides 1, not 22, not 2, and not 11. Can you think of three more numbers that don't have any factors besides prime numbers that you could add to this category? Let's talk about one more counterexample before we move on. Let's look at the square root of minus 25. So essentially what it's saying is there has to be two numbers that multiply together to give you minus 25. So let's look at our two options. If we have 5 times 5, well, that gives us 25. Is that equal to minus 25? No. Let's do minus 5 times minus 5. Well, two negatives make a positive, so that gives us 25. So that doesn't give us minus 25. This is an answer that has no solution. So in terms of negative radicals, we could not simplify this question. It doesn't have a solution in real numbers. It has a solution in the complex numbers. And just for a little interest, I is equal to the square root of negative 1. So if you really wanted to put an answer down for this, the answer would be 5i. Just a reminder that the perfect squares are the numbers that we've been playing with in the unit. So we can talk about 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, etc. So you should have a list of perfect squares handy as you're solving to simplify radicals. Let's look at the first radical rule we're going to play with. It says the square root of a times b, all under one radical, is equal to the square root of a times the square root of b. So for example, if we take the question, the square root of 25 times 4, and we apply the rule, so as you can see, this is splitting up the 25 and this is splitting up the 4. So now let's play with this versus a left side and a right side and see if we can get them to be equal. So first of all, if we play with what's under the radical and we get the square root of 100, we all know now that the square root of 100 is 10. So that side equals 10. Let's look at the right side. Well, what's the square root of 25? 5. What's the square root of 4? 2. 5 times 2 is 10. So since both sides are equal, we can show that we have just given a great example for rule number 1. We're going to be using rule number 1 to simplify radicals in the next steps. Let's apply the first two concepts we've been looking at. 1 is finding factors of numbers that are perfect squares, and 2 is using the radical rule number 1 we just talked about. So first of all, let's split up the square root of 48 into two parts, where one part is a perfect square. So that would be 16 times 3. What is the square root of 16? 4. And the square root of 3 is just the square root of 3. Remember we talked about putting in the little 2, because as we progress through the rules, we're going to be using that. So if you can, definitely take that into consideration. Now, the square root of 25 is a perfect square, so that answer is just 5. Let's look at the square root of 32. Well, the square root of 32 can be broken into two parts, 16 and 2. The square root of 16 is 4, and the square root of 2 is just the square root of 2. Let's look at the square root of 98. Well, that's equal to the square root of 49 times the square root of 2. And the square root of 49 is 7 times the square root of 2. These are the basic type of questions you'll be asked to do. They do get more complicated as we add in variables of higher degree. Let's look at the 4 questions on this screen. Square root of 42, square root of 22, square root of 6, and square root of 17. If you recall from our previous discussion, these numbers don't have any factors in them that are perfect squares. So if a number doesn't have any factors that are perfect squares, lucky you, it's already in reduced form and there's nothing left to do. So these are all in reduced form. Alright, the next piece of the puzzle is when we start working with our coefficients and our variables. So for example, the first question I have here is the square root of 25x squared. So we can do the same procedure. We can apply the rule, I should put my 2's in here, and split up 25 into 2 parts, and the other part is x squared. Now this one I made it easy because 25, the square root of 25 is 5, and the square root of x squared is x. So this has a nice answer, 5x. Let's have a look at 17x squared. If you remember from our previous discussion, we know that if we split this up into its 2 parts, that 17 is a prime number. So this is already as reduced as it gets, so you get the square root of 17, and the square root of x squared is x. So in this case, you're going to have 2 parts. You're going to have your radical, and you're going to have your variable, and that's okay. All right, let's continue this discussion with some trickier questions. So let's break this up into, let's turn that back to blue, the square root of 12 times the square root of x squared. Now, 12 has a factor in it, that's a perfect square, which is 4, so we can break this up one more time and leave this as x squared. Now we can reduce each piece. The square root of 4 is 2, the square root of 3 is the square root of 3, and the square root of x squared is x. So that is in its most reduced form. 50x cubed. Again, this one we can split it up, so we'll just split up the 50, try to remember to keep our 2's in there, and split up the x cubed. Now, each of these can be split up again. So the square root of 50 has a perfect square factor in it, which is of course 25, times the square root of 2, and if we undo our exponent laws, we can break x cubed up into x cubed and x. So, what is the square root of 25? 5. What is the square root of 2? Well, just the square root of 2. What's the square root of x squared? X. And the square root of x is just the square root of x. So we've taken something that had 2 parts, and it now has 4 distinct parts. The 5, the square root of 2, the x, and the square root of x. And that's in its most reduced form. Alright, here's our last question of the video, and you can see that I've made it a little bit more complicated. I have 32 x squared y cubed z4. So again, we'll just start with applying the rules, and we just split it up. So this is sort of like the distribution in the exponent section where we just sort of do this mindlessly. We just take each term and give it its own square root, and then we deal with it as appropriate in the next step. Alright, so 32, if you remember we've used this number before, square root of 16, square root of 2, square root of x squared is just x. Y cubed will be broken down into the square root of y squared times the square root of y, and if you remember correctly, z squared times z squared will give you z to the power 4, so the square root of z to the 4 is z squared. And now we can simplify. Square root of 16 is 4, the square root of 2 is the square root of 2, x is reduced, the square root of y squared is y, the square root of y is just the square root of y, and we have z squared. So if you can do this question, I think you've learned all the skills you need to know for part 1, radical rule number 1.